Okay, today we are going to check how to configure bonding on Linux via sysfs file system. Okay, so let's log into our server. Alright, and first we need to check if our kernel supports bonding, so let's review one of the configuration files under the boot directory. And currently we are booted in 3.14 with physical address extension feature. Okay, so let's review this particular file. Alright, and we do have a support via kernel module. So now we need to check if it's actually loaded into the kernel. And just to be sure, we can always check if the actual object file is present on the file system. And it is. So now let's see if it's loaded into the kernel. And it is not, so now let's use probe here. Alright, there we go. If you do not have this configuration file under the boot directory for some reason, you can always try to check procfs. If your kernel was compiled with a proper parameter, you should have a config.gz exposed directly under the proc directory. Basically, this is the same file, just compressed, so we'd have to use zcat or gzip to decompress it and read it. And just to quickly show you what I have in mind is, let's go to sources and let's check, for instance, this kernel. Alright, and under the general setup, you have this parameter. You can compile it as a module, or compile it directly into the kernel and just check this one. And after the compilation, and when you boot up with this kernel, you should have config.gz under proc. Alright. So now when we have our kernel loaded, our module loaded into the kernel, we have to create our bonding interface. You should have, after you've loaded the module, or if you already had the code directly compiled into the kernel, you should have the following file under the sysfs bonding masters, which lists all of the bonding interfaces which are currently available to use for you. So by default, there is always bond 0, which is created by the driver itself. But we will create our own. So let's do that. Let's call it main bond masters. And you can name your interfaces, your bonding interfaces, whatever you want, but they have to be 15, maximum 15 characters in size. So if they are longer, then that name will be simply truncated. Alright, so before we set our mode, in the first example, I will show you how to use a basic round-robin algorithm, which is used for load balancing, and then we will check how active backup mode works. So first we need to make sure that the interface is disabled before we will change its mode. So let's do that. And now let's review its setup. Alright, and this is actually what we want. This is our standard round-robin load balancing algorithm. This is the string which describes the mode, and this is the equivalent numerical value. So you can use either the string or the integer to define the mode. So we will leave it as it is. And now we have to set the monitoring facility. You can use MII or ART protocol for that. We will stick with MII in this example. And to activate it, you have to set an interval. So we will set to 1 second. Alright, and now we have to set our slaves. So let's see what interfaces we have on the system. This is IP-Fire distribution, so they have a bit different naming convention here. Everything depends on what side of the network the interface is. So the green basically stands for your local interface. The red one is the one which should be connected direct to the public network. And there's also blue interface for wireless, I guess. You can also see Ethernet 1 because it hasn't been configured, at least from the IP-Fire distro perspective. So I've just added this PCI card to the chassis right before I started recording, because this interface is faulty. It basically is dropping packets on very huge rates, so I'm not able to use it in this video right now. So we will stick with Ethernet 1 and red 0, and those are going to be our slaves. Alright, and because to set as a slave, we need to first flash the IP address and disable the interface in question. So because I'm connected via SSH, I first will have to disable the interface, which is not currently used by the system, then set an IP for our bonding interface, activate it and log in via this bonding interface. So I believe that we are currently using Ethernet 1. So we will have to take care of red 0 first. Alright, so let's make sure that it's disabled. It's not. Alright, and let's use it as our slave. Alright, now I'm going to set an IP for our bonding interface. Alright, and also we have to activate the interface. Alright, so now this machine should be reachable with this IP. Alright, so let's SSHN with this IP. Alright, and now we can disable our Ethernet 1. Alright, and let's flash the IP. And use it as a slave. Alright, so now our bonding should be up and running. Whenever you are configuring bonding, you can always check the kernel ring buffers, because every message should be logged by the bonding driver should be here. So as you can see, there is info that we've had a slave, that it's in up state, you have duplex speed set up here presented, and so on. Alright, so now this terminal should be deactivated, so let's close it. Alright, so let's start pinging our server, and now let's check how packets are distributed between our slave interfaces. You can use ifconfig IP to check rig takes queues. That's your call. I will go with procfs. Alright, so because this output is horrible, so let's check what we actually want to see. Okay, so we want to second, third, 10, 11. Alright, so 2, 3. Alright, so let's make something fancier here. Alright, we want to see red, our bond interface, and we want to display packets received and transmit. 7 from ProcNet. And it will be also good to see the name of the actual interfaces. Alright, so right now we can see actually here our SSH traffic and our ICMP traffic. And as you can see, the statistics are changing for both interfaces. For instance, Red 0 is receiving, this interface is transmitting and receiving packets. This one is currently transmitting it. And if you add those values together, you will get the total of your bond interface, showing you that this traffic is divided between those two interfaces. So I will disable now one of the interfaces to show you that we will not lose the connectivity because we have a second slave. And then we'll move to our second example. Alright, so I've disabled Ethernet 1, and as you can see, now the traffic was moved, the entire traffic was moved to Red 0. So it starts to transmit packets instead of the Ethernet 1, and we are still connected to the server. If you will check the message again, you will see that the Ethernet 1 link is down and it's currently disabled. So I will just connect it to the switch again. Alright, let's check it out, and now it's up. If we go back to our watch, now the traffic is back to Ethernet 1. Alright, so let's check how the active backup works. So first I will have to flash the entire configuration. Release slaves. Alright, we should have our machine up and running under this IP. And which interface is currently in use? Red 0. Alright, so because the script I wrote also disables the bonding interface, we will have to create it again. As you can see, only default bond 0 is being used here. Alright, so let's create again our bond interface. Let's disable it. Alright, now we'll have to set a different mode, active backup. So that's 1 in integer. I believe that in string it should be active-backup. But I can be mistaken. I usually go with integers. Okay, bonding mode. All right, and in terms of monitoring facility, we're going to use ARP in this example. So we'll also have to set an interval. We'll go with 100 milliseconds this time. ARP interval. Right, and we also have to set an IP target for this facility. So we will use IP of this machine. Right, we are behind NAT, so let's check it like this. Alright, so that's going to be our ARP target. Alright, now you can also set filtering and validation of the ARP packets. For instance, you can, just to be sure that you are not flooded, some spoofed packets, you can set it in this way that all only active slaves will be checked, or all of the slaves. The active slave is the one which is currently handling traffic. So let's set it to 1, and that means that only the active slave is going to have ARP packets validated. So let's set it like this. And now we have to set our slaves. So because we are logged in via red 0, we will set Ethernet 1 first. So let's check if it's online. It is. So let's down. Slaves, and we'll also use it as our primary slave. Alright, setting Ethernet 1 as primary slave. And now I will set an IP for our bonding interface, make it online, and log in to the server via its IP address. Add, let's set it again to 41. Custom address. Alright, let's make it online. Alright, now let's see if it's available to us. And it is. So now let's log in via SSH. Alright, so now we will have to disable red 0. Yeah, alright. Flash the IP and set it as a slave. Alright, so our bonding should be up and running, so let's go back to our watch interface. Our Ethernet 1 is the main interface, so as you can see, both statistics for both incoming and outgoing packets are increasing. You can also see that red 0 is transmitting some packets, and this is our ARP traffic. So let's close this terminal. So open the window. Let's start pinging our server. If you are going to check this interface with TCP dump, for instance, you will see only ARP traffic here with IP target set to the target which we've set previously. So just to remind you, classnet and this is our target here. So now the entire traffic is going through our primary slave, which is Ethernet 1. So now I will disable Ethernet 1, and we should see that traffic is moved to red 0. Right. Alright, I've just disabled Ethernet 1, and as you can see, the entire traffic was moved to red 0. And again, to prove that, now if you run TCP dump, you should see some more traffic, and this is basically, for instance, we should see our SSH traffic, and there it is, and our ICMP. It's pinging, it is pinging. Okay, so let's check the ICMP, and there it is. So now traffic is handled by red 0. And If the Ethernet one goes back online, the traffic will be moved to the primary interface back again. So I will connect Ethernet 1 to the switch again, and we should see that. Alright, so I just connected to Ethernet 1, and as you can see, traffic is back on this interface. If we go with TCP dump again, you will see that ICMP is gone, and we are back with our monitoring ARP packets. And if we review Ethernet 1, we can see our SSH and our ICMP. Alright, and also in the message, right, you can see that we were switching between our slaves, so making interface red 0 the new active one, and then making interface Ethernet 1 back online. Alright, so basically that's it. There are some other features which you can use with bonding, different algorithms to use for load balancing on redundancy purposes. So I suggest to review bonding documentation for that. And just have in mind that this configuration won't be preserved, so it will be flashed during the reboot. So if you want to set this permanently, you have to include it in your init scripts, in run controller directories, or some other facility which is used on your Linux distribution. You can write your own scripts in, or just include it in RC local, for instance, something like that. Alright, so if you do have any questions about that, please do not hesitate and just ask them in the comment section, or just send me an email. And thanks for watching.